Hey guys, I'm tired. I'm Chris. Welcome to the assembly video for the Mark II LongMill CNC. We've been working really tireless here at CNC Labs on the development of this new machine. We really try to be intentional about every aspect of using this machine. And what that means is that not only have myself and the rest of the mechanical development team worked hard on designing the machine itself and going through iteration after iteration after iteration to really question every aspect of, well, does this need to be here and can we reduce this extra part here, etc. But we also try to incorporate other aspects of using the machine, like how the assembly process is for you, what sort of other resources we make available to you so that you can learn more about using your machine and how you can use that machine, as well as building out software that you can use for it, having a community to engage with, that sort of stuff. So the reason you see this fully prepared machine here is because this is what we're going to be putting together today. We're going to be following through. It's a completely unscripted video that we put together. And the reason why we don't script it is because it allows us to kind of show you any sort of bumps along the road you might experience. It gives me a chance, as one of the main designers of this machine, to give you some extra insight as to how the machine works and how it operates and the considerations we made along the way. It also gives me just time to explain things and show the assembly of the machine as it happens. So this video has very little editing on it. You basically can just start it, and the idea is that you can follow along. We're not going to cut to stuff assembled. You can just do it at the same pace as I'm doing it. And if you're particularly faster at it than me, then that's fine too. You can speed up the video and do it at whatever speed you want to. The cool thing is that we're going to be showing not just putting the machine together, but also mounting it to the surface, showing a little bit about how the software works to control it, and we're also going to be making your first project on it. And pay no attention to this. This is just a scrap piece of wood I grabbed, but this little LongMill writing here, that's what we put together on the machine here. Went together really quick, done in just a minute, and that'll be something that you can decide later on in the assembly process, where we got a couple projects you can choose from and you can run whichever one that you prefer. So if you are starting this video now and you haven't yet found our instructions, I'd encourage you to go onto the website, and I'm going to show more clearly on the computer soon what that looks like. And then once you can find that area, then you can start with the assembly and follow along with me on this process. So I'll see you guys as we go through. All right, so we're going to start opening up the instructions on the website. And you don't need to know how to do this by heart. We've got a nifty link written on the box here, and this will take you right to the instruction manual. But if you don't have a QR code scanner and you don't have, or you don't want to, type in a long link, you can go onto the website as well. So I've just got a computer open here for me, where I'm going to be following along on the assembly instructions, so that at some times we can kind of show you what I'm looking at on the screen, so you can match that up to what you're doing in real life. So just to get there, we go to the LongMill Mark II resources, and we're going to scroll down on this page. This is the welcome page, where it discusses what you can find in this area that we call resources. And I would highly encourage you guys to either, if you haven't checked it out already, or you finish assembly and then you want to learn more about your machine, I'd highly encourage you guys to go through this area. There's a lot of concepts for basics about CNC machines. There's covering of the software that you can use for your machine if you haven't chosen the software you want to use yet. And then there's obviously the assembly section. And so there's also a button down here for assembly, but I'm going to use the one here. So you've got your machine here. This is the box that your LongMill MK2 will arrive in, whether you bought the 30 by 30 or the 12 by 30. Believe it or not, the whole machine fits inside this box, so don't be scared if you didn't have anything else. Very rarely do we ship any external items that might not have fit inside. You'll see when I open this up that this includes not just the machine, but also all of your other stuff, including, you know, the extra add-ons and goodies that you bought for yourself or that we might have included. So we're just going to take our time here going through the unboxing, and counter to the name, we're not actually going to unbox every little thing on the machine, but we'll kind of go through the assembly one step at a time. So basically what you can do here is you can choose if you're going to download the instructions or if you're going to just read them on our site. These online instructions will be the most up-to-date ones, so you can open them up to follow along with them. If you're running the video separately, the online instructions will always have the most up-to-date information. And also, if we make any iterations on the MK2 design, you'll want to make sure that you are using the correct version of instructions when you're assembling your machine. So currently I'm assembling the original, MK2. It's at its first release right now. And so if you've got another MK2 that says something else crazy on it, then that's what you want to be watching out for. So that's my PSA to you. You're not missing parts or anything, just make sure you're using the right instructions. But right now it's very simple, there's just one set of instructions. So let's get this box open. Now, what I like about filming these instruction videos is that not only do I get to show you how to put the machine together, but I also get to talk a little bit about why the machine is designed this way. And that's pretty fun for me because I was actually a part of not only designing the LongMill MK2 itself, I'm the lead developer on it, but I was also a part of designing the packaging for it, some of the accessories for it, the majority of the assembly instructions were also something that I worked on, so I like talking about how they've all fit together to make your CNC experience as good as possible. So we're going to just read this whole unboxing section and make sure that everything's covered. It will give you a bit of a starting point of understanding what you'll find in the machine, what sort of things to consider before you start machine assembly, so that you're not feeling overwhelmed. And you can kind of understand how we're going to show you the assembly process. So you can see the picture here. It's got the transparent version of the box, and that'll perfectly match, what you have in real life. And so I've got, this box is actually a bit in the wrong spot, but I've got the variable box here. Actually, I'm going to twist this around so you guys can see the box a bit better. And then if you bought the Makita as an optional thing, you've got that there. And then here you've kind of got the trio of boxes stacked on top of each other, which is your gantries, your welcome items. This might for you come in different packaging, but it all contains the same stuff. And your motor box. And then at the bottom is the rail box. So what we're going to do basically is we're not going to, as I said, we're not going to unbox this in its entirety, but we're just going to take it roughly into the individual items so that you can kind of visually see the parts that I'm talking about as we go through the assembly, so that I'm not just telling you, oh, open up this nameless box. And this is the rail box, it's the heaviest box. So what does a basic unboxing look like? Well, actually, I'll start with this box here. The welcome items. If you haven't found this video yet and you just decided to open your box, hopefully you found this box. It's got the letter in it that tells you to find this page. So congratulations, you've, I don't know, I've achieved some sort of cyclic thing here. The great thing about the coverage on this page is that it's got some great information on, connecting with the community and us thanking you for buying this machine and just being involved in this cool CNC thing that we all like to do here. It also includes some safety guidelines. I would highly encourage you guys to read these. Here, we'll give a quick close-up of that. I'd highly encourage you guys to read these because, at our company here, we're making the machines accessible to you guys. We're trying to make it as easy to use as possible. But alongside that, we want to make sure you guys are being safe with your machines. If you're not safe, then you're not going to have a good time. And we want you guys to be able to have a good time with your machines, make cool stuff, enjoy yourself. So that's what that's for. All right, I'll put this aside. Yeah, so alongside that, you'll get some stickers and some other stickers. You can put these wherever you want, on your toolbox, on your machine. Go wild. And you got some tools here. So these two Allen keys, which is an M5 size and an M3 size, also known as actually don't worry about it. The Allen key sizing is kind of weird. And a wrench. And all these parts I'll show you in use later on. But basically, they, for the most part, are the only tools you need for the entire machine assembly, which is quite surprising, but it's true. And I'll just set this aside because, actually, this LongMill sticker is kind of cool. There you go. Okay, the second box that you probably would be drawn to is this one here. So the reason we call this the variable box is because it has all of the variable items in it. It has some stuff that you will need for basic machine assembly, but it also has, ta-da, it also has other things that you ordered, such as we got the touch plate in here, the add-on pack. We've got also here it is, magnetic dust shoe is in here. So that's pretty cool. If you ordered that, you'll see a box kind of like this. So I'll just set this stuff aside because any add-ons that come with the machine are assembled after the machine itself is assembled. So the stuff you will need in here, you got a control box, e-stop, and these two parts that you use for the machine. And I'll explain them more as I reach those steps. Okay, got our router. I'll quickly open up these boxes too. Here you'll find the steel carriage plates, or gantries we call them, for the X, Y, and Z. The XZ gantries are already attached to each other out the box. And the two Y gantries are here as well, with some padding between them. You'll see those in detail more later. In here we've got the stepper motors for the machine and the wires. Ta-da! These we will assemble also later on, so don't really need that box right now. And lastly, we'll open up the rail box. This rail box is where the real meat and potatoes are of the machine. Okay. Yeah, so we got our steel feet in here, all nicely wrapped up with each other. If you ordered the dust shield add-on with your machine, you'll see the dust shields in here, and I'll set these aside for now. And then we got the main stars of the show, the rails. This is a Y-axis rail and another Y-axis rail. And you might find a little bit of padding in here just to keep everything protected. And then we've got the X-axis rail. Look at my bundle of stuff. Okay, we'll just do a little bit more pulling things out because these rails actually contain other parts for the machine. Because you're probably thinking, you know, there's no way this is the whole machine. You're right. We've got other stuff inside the rails. So these are the drag chains and lead screws. And then there's another really cool box inside here that you can just pull out. And here we got some hardware bags. We got the power supply here, a USB cable, and the middle feet for the machine. And I can put that box aside. This packaging was really fun to design, can I say, because one of the things that makes the LongMill, the original LongMill or the Mark II LongMill design so easily accessible for people is that we really work hard to get it fit inside a really tight box so that we can ship it almost anywhere in the world with very little cost. And it also means that, you know, if we were shipping it in multiple packages, you know, one could get lost, or you might have to pay more for duties on one of them, all this sort of other stuff. So we really wanted to keep it nice and condensed. And with these rails, it didn't make it easy because they're very bulky. They take up a lot of space, but we were able to sort out how to fit actually more stuff in into the small space. So this is everything. And you know, you might still ask yourself, oh, this still seems like not a lot. And you're right, the overall part count of this machine is very low. And the whole reason why the Mark II exists is because we redesigned it to use as few parts as possible and still accomplish not just all the things that the original LongMill design did, but even more so. So, you know, you'll see how this all comes together. We've got these two hardware bags here, and they're kind of set up so that you'll mostly go through this green one first, and then you'll get to this yellow one near the end of assembly. So basically what I'm just going to do here is I'm just going to clean up my space a little bit. I'm going to set off to the side all the stuff that we're not going to touch until later on, and then we can just kind of focus on the initial assembly. So things we can set aside are electronics, and that includes the e-stop here and the control box. Okay, I don't want to make that kind of weird. Just going to put all that there. Don't need the router yet. And let's see what else. Well, I'll put this off to the side. And yeah, I think I'll keep all of this other stuff here. All the rails I'll just leave off to the side. The drag chain and lead screw, yeah, we'll put these off to the side as well. With the feet and the other feet. This is kind of going to be our starting point. We're going to have our hardware bag here, our router mount, and our other aluminum piece, which I'll talk about once we open it up, and the gantries. So we've kind of got everything laid out. Let's kind of establish what you should expect to see as you're moving through assembly. We've got our tools here still, the Allen keys and the wrench. You can also have on hand for later stages of the assembly a small flathead screwdriver, and also consider having a drill or a screwdriver where you can drive in wood screws, because that is going to be needed to attach the machine to your platform. I'm going to be using actually this roughly 4 foot by 4 foot sheet of MDF to mount the machine to. It's not the like primo version of what you can use with your machine. It's the most bare bones version. And so if this is what you want to start with, that's great, because it's readily available in a lot of big box stores. So you can just go pick it up and use it alongside your machine. And then when you have more resources available to you, you can always upgrade your layout to do more stuff for you. Some other things to cover before we go into the assembly is if at any point in time you think you have missing parts or broken parts, we would encourage you to make sure you've checked through everything. Make sure you're looking at the right instructions. And also understand that a lot of these parts, especially the smaller parts, we ship a lot of extras with the machine. And so if you're saying to yourself, it doesn't seem like I have enough parts for this step, just double check the rest of your kit and see if there is a spare one there for you to use. Even things like the feet, if there's an issue with how they're tapped or the hole placements or something like that, they're set up so that not all of them use the same geometry. So you can try swapping it out for a different foot and seeing if that'll work for you. And obviously, if none of that stuff works, you can feel free to contact us. Some tips that we like to give when you're doing assembly is, don't rush it. This is actually kind of fun to do, is put your machine together. You're seeing how the sausage is made, per se. And also, you're kind of getting to know your machine a bit more. The hands-on part is really fun. And, we try to make the assembly, even though this is a complicated machine, we try to make the assembly as easy as possible. And so hopefully you don't get stressed about it or anything like that. I like to, when I'm doing assembly, have a bottle of water along with me so I can stay hydrated and pace myself. But if you want another cold drink alongside, you feel free. The number 2, the instructions are pretty clear. We work really hard on every aspect that you interact with the machine, and the instructions are no exception. These are tested pretty thoroughly, and so we've got big pictures that you can look at, and actually the pictures themselves most of the time have all the information you need for that step. We've also got text that you can read, and make sure you're reading everything. If you feel like you're the type of person that misses things or skips steps or whatever, it's good to make sure you got all your bases covered. This isn't a race, so we guarantee, you can go pretty slow and you'll still be done assembly pretty quickly. You'll see today, I'm going to be taking my time and we'll be done in no time. Some other things is you can be looking out for these symbols that we like to use visually in the instructions. Sometimes this is showing, where a part starts and where it ends up, or, how much you're tightening down on something. There's caution marks for when you want to look out for things. We've got blown up, alternate views if you want to see something close up or from a different angle. There's the tightening arrows are probably the most important ones, because some steps you really want to make sure you're not reefing down with your Allen key on your part. And some steps you do want to make sure you're doing that, to a certain degree. The assembly, you can do it all just with the Allen keys and with the wrench. So you're able to kind of by hand gauge the tightness of things. You don't have to be really technical with it. you know, the machine is designed for a wide range of people to put it together. So, you know, don't try to be too on top of these sorts of things, but definitely don't reef down on something if it's just supposed to be loosely tightened down, which is indicated by a blue rotation arrow. You're just slightly tightening down on it. Sorry, you're kind of like placing it. You're not tightening down on it, I should say. Yeah, we've got the other thing to keep in mind is I'm going to be referring to some things with some more technical terms like the x-axis and the y-axis and the z-axis. The x-axis is the one that'll span this way and allow the machine to move side to side. The y-axis will span this way with the two rails and allow you to move the machine in and out. And the z-axis is going to be your up and down. That's going to carry your router to make the depth for the cuts. So we're going to move on to the next page now. You know, you guys got this. It's not very hard. You can always reach out to our community. You can reach out to us. But trust me, you'll be done this in no time. And yeah, just remember to have some fun along the way. So we're going to start out with the X and Z axes. And we're just going to open up this bag here. So we got a lot of goodies in here. Actually, I might grab a seat here. Okay. And what we're going to be starting off with is we've got this one bag here with the plastic nut blocks. Sometimes I like to call these robots because they kind of look like funny robots. We're going to be starting off as well with this small bag here of brass nuts. And there will also be another small bag. This will be the only bolts bag that might be unlabeled. And it just has a couple bolts on it that you want to be using. And lastly, there will be this one labeled M5 nylog nuts. And we'll be pressing these into the blocks. The rest of this stuff you can just set aside for now. So, starting with this sub-assembly, I'm basically just going to be taking out everything that's in the bag and putting it together. You can see on this first step, we're starting with the brass nuts, and they use these tiny little set screws here. And these parts are going to be used to basically tighten down on your lead screw. You can imagine the machine is lead screw driven, and so on one side, you've got a coupler from the motor to the coupler, then the coupler is attaching to the lead screw. The machine's driven by the lead screw, but then on the other end, the lead screw needs to be constrained so it doesn't wiggle side to side. These are what go on the other end. And you're just putting these set screws in just, one or two turns, because if you turn them in too far, then the nut itself won't be able to thread onto the lead screw. All right, with the brass nuts finished, we'll just set those aside and pull out the plastic robot heads. All that we're doing here is we're just preparing these plastic bricks or blocks or robots or whatever you want to call them. You only need 4 of them, so the 5th one is a spare, and if you go to assemble one of the other 4 and it doesn't work, you can grab the 5th one. But these, similar to the brass nuts, are a part of the motion system of the machine, and these are what actually bolt onto the steel plates to allow the plate to move along. So all that we're going to be doing at this step is we're going to be taking these hex nuts and making sure that the little rounded part is facing up, and then we're going to be pushing them into the blocks. And you should find that in most cases the nuts go in quite easily. I mean, these ones are just dropping in. On some of the nuts, this plastic has a little bit of deviation when it's manufactured, so it might require more of a press fit. And in that case, sometimes I'll just use, for instance, one of the steel plates to press it down in place, but it shouldn't require too much force. So I've got all the nuts in there. And I'll just be putting these bolts in the threading on the lip as well. So those just thread in like that. And we're not going to thread them in all the way. Just going to start about, or going to leave it about part way along the gap, as you can see in the instructions. These guys are really cool because later on we'll show you how they go onto the machine and why they're called anti-backlash nuts. Because you can, basically this bolt that we're putting in, you can tighten it down, and by tightening it down you can pick up the slack that the machine might develop over time in the movement, and by doing that actually ensure that your machine stays accurate for long periods of time. So that step is done. Next, we're going to be grabbing this wrapped up guy here. It's going to be, remember I was opening up the variable box and there was, you know, some of the other stuff in it, and then I grabbed these two guys. This is your mount that attaches to the Z-axis and puts your router goes in here. And this is what we call the Z-axis motor mount. I'll show you where this goes on the assembly. But let's open this up. Ta-da! So where we'll be starting is from that green hardware bag that you had, which I've just set everything off to the side for. There will be a bag of bearings. These are flange bearings, and we're just going to take two of them and stick them in the top and the bottom of this piece here. They should actually have a little bit of looseness to them, because they don't need to be in there very tight. That step was pretty easy. So we'll move on. Okay. At this step, you're going to need one of the lead screws. And if you remember, I pointed those out earlier on. Those are actually within the drag chain here. And so I'm just going to take my knife here and free up the drag chain so that we can gain access to the lead screws inside. Turn this around and get at the other side. One thing that we try to make sure of when we design the packaging for this machine is we try to keep everything as minimized as possible. When I say minimized, I mean you do as much as is necessary to make sure the parts stay protected during transportation and no more. Any over designing of the packaging, all that really leads to is well, we can make it look fancy for you guys if you want it to look fancy. But I think some people forget that if you're opening fancy packaging, you've paid for it in a way. You know what I mean? If you get a really fancy, I don't know, drill or whatever, and it's coming in this like really fancy packaging with the carrying case and all that stuff, it feels like you got that stuff for free. But in actuality, when you bought the drill, you bought those things as well. And so what we try to do is we just try to make sure that the machine gets to you in one piece without anything extra or anything that we feel is extra. So then you're not having to, you know, inadvertently pay for all these other things. You know, you're just paying for a little bit of plastic wrap, some, you know, elastic bands. And a lot of our other packaging is paper because not only is paper cheap, but also it's recyclable, which is great. You don't have to feel bad about having a whole bin full of styrofoam that you don't know what to do with. So you'll notice here that I basically just looked inside the 2 drag chains, and there'll be 4 lead screws in here, depending on if you have the 12 by 30 or 30 by 30. You'll either have 1 long one, 2 medium length ones, and 1 short one, or for the 30 by 30, they'll all be long and then the 1 short one. And you just need to find that short one for this step. Otherwise, I'll put the rest of this aside for now. So I'm just going to take this short lead screw here, and we're going to thread on this nut. And getting it on might be a little tight at first, but you know, it should slide on smoothly after that. And we're just going to put it on a short length. After that, we're going to take this and stick it through the bearings. And you just need to give it a little bit of a wiggle as it's going in. And then you should be able to set that down. And now we're going to be grabbing one of the other bags here. This bag has the couplers in it. And we just need one for this step, so I'll just take out the one and leave the rest aside. Okay, so we're going to take the coupler here, and there's going to be basically one side that fits on and one side that doesn't fit on because it's too small. So find the side that fits on and, you know, put it all the way on. And we'll be using the small M3 Allen key because the coupler has the M3 on it. And just use it to tighten up the side that you just put on. There's going to be 2 screws there, and you only need to tighten one of them right now, and it'll be the one on the side that you just put on. And you're just going to be using that Allen key. And as the image suggests on the site, you're going to give this a really nice tighten down. You know, feel free to go semi-gorilla on it. And now that should be really firmly attached onto the lead screw. And then this is a part of the assembly that we do here, but we also do it later on a couple other times. So now's a good time to get used to it. But basically what we're going to be doing is we're going to be holding onto the coupler on one side and holding on to the brass nut on the other side and turning them against each other until they basically sandwich the bearings. So you're kind of twisting them against each other so they're sandwiching the bearings together. And what we want to do is we want to hold these twisted together as they're sandwiched, and then we're going to take our Allen key again, and we're going to tighten the set screw on the brass nut. And we're going to tighten that all the way up while we're making sure these are twisted against each other. And we're going to tighten that down real hard so that now that brass nut won't go anywhere. And now that these are both tightened up against each other, you should notice that, you know, this feels really strong. Like it feels like it's not wiggling anywhere. You know, it's spinning, obviously, but that's about it. And that's exactly what you're looking for with this sort of assembly. You don't need to, we're not like reaming down super hard in terms of twisting them together. We're just wanting to make sure they're twisted together enough that, you know, there's not any looseness here, because this part here, this is going to move your router up and down. So if there is any looseness, then when you plunge into material or what have you, if this wiggles a little bit, that's going to affect how you cut. So I'll just set that back down again. And actually, I'm going to set it off fully to the side because we're going to bring some other stuff in front of us now. What we're going to grab next is we're going to grab this bag of V-wheels. Got some bolts here, the M5 bolts. We're going to have the nylock nuts again, the eccentric nuts, and the M5 washers, and the XZ Gantry assembly. So at this point, basically we have everything out of the green bag except for the bearings and the couplers. Any spare parts you have, keep them set aside in case you need them later on, or when you're doing maintenance on your machine. So we're going to start with these wheels, and these wheels are the main motion system of the machine. They ride along the rails. The rails have an edge on them, and these wheels have a groove matching that edge, and that is what allows the machine to move where it needs to move to, but still be nice and solid. And because we're going to be taking these bolts and putting them through the wheels, we need to just make sure that the spacers that are between the two bearings of the wheels are in the center. If they're off center, the bolt can't go through. So we're just going to be keeping an eye out for if they're centered, and if they're not, we're just going to be taking our Allen key here and just pushing them back into the center. Some of them might be a little bit harder to push in, but just use your finger force, take your time. Now, if you've never seen machines with these sorts of V-wheels before, you can see them in other areas like other hobby CNCs. You can see them on 3D printers, laser cutters. They're actually very widely used. And the reason why is because as opposed to a system with linear rails, for instance, or there's other sorts of linear motion systems that exist that you can use with plastic bearings and stuff like that. These are sort of, well, A, they're lower cost than some of these other systems, but B, they were really purpose designed for more dusty environments. If you think about a linear rail, we do have linear rails on the machine on the Z-axis because we like having that extra amount of rigidity on the Z-axis in particular. But if you have a machine that's fully linear rails in a cutting environment, you really need to do actually quite a bit more maintenance on it in order to keep it clean and also oil the bearings as they're moving around. And so for someone who's more of a beginner, if you're not on top of those things, your machine could get ruined, or you might have to buy new bearings, or you might have to buy new rails, or anything like that. So the nice thing about the wheels is, even though they still require a little bit of cleanup, they are just a soft plastic. They move along the aluminum. The plastic is still very tough, and so it doesn't bend or move out of the way really. And so you can still get really accurate cutting in a system that is more easy to maintain. And the other nice thing is that linear rails, over time, they will wear out. And just like this will wear out, anything that moves over time will wear out. The nice thing about the system that we've used here is we use, for these wheels, we use these nuts that are off-center. So what you'll do is every time you're mounting these wheels on the plate, there'll be a pair of wheels that's fixed in place, and then another pair of wheels that can be, they use this nut that's off-center, so that when you twist the nut, you can adjust the location of the wheels. And so the great thing about this is that this actually gives the machine a lot more longevity in terms of how you use it. as the components wear out over time, and this is similar to the anti-backlash blocks, you can use this built-in adjustment system in order to offset for the wear that the machine experiences, versus the wear that a linear rail or a smooth rail or whatever would experience. Anyway, so we're going to be taking these bolts here and stick them through the wheel, and on the other side we're going to be putting a washer. So I'm just going to dump out these washers as well. And you can think of this as another one of these kind of sub assemblies, because these get assembled onto this gantry sub-assembly, which then gets attached onto the overall machine. And remember, when you're putting these on, the direction doesn't matter, but remember you're doing a bolt, and then a wheel, and then a washer. And remember the washer because it makes sure that the wheel is offset from the plate that it gets mounted to. And we're just going to do 12 of these, so you know. I hope you guys have been enjoying the assembly so far. Parts have been pretty straightforward to put together. I like to hit you guys with a lot of knowledge, but if you want, you can just tune me out. I don't mind. I should also mention that the direction of the washers doesn't count, or doesn't matter either, which side you have the smooth or the dull side of the washer, doesn't matter at all. And you'll see that by the end of it, you should have some spare wheels and spare washers and stuff like that. So I'm just going to take all these and set them aside. You don't need the washers anymore for any other step. You don't need the wheels anymore for any other step. So we'll just set those aside. For this particular step that is going to come up, we're just going to use 4 of these wheels. So I'm just going to take the other 8 that I've pre-assembled here and set them off to the side. By the way, I have them standing up. You don't have to stand them up. It's just a fun thing to do with them. Okay. Perfect shot. And by perfect, I mean it wasn't perfect at all. Okay. So we're just going to free up this gantry assembly here. We use the plastic wrap to hold it in place during transportation, because this is probably the part of the machine that has to be put together the most accurately, and that's why we do it for you instead of you having to do it yourself. We have special jigs to make sure we can get it all aligned nicely and do it relatively quickly. You know, when you go and you grab this, you should be able to slide it along and notice that the movement is quite smooth. If it's you'll probably see that it's a little oily. You know, we try to keep it kind of clean. The oiliness it makes its way onto some of the steel parts sometimes, because it's important that the rails stay oiled. And so if you're going to take a cloth, feel free to dry off, or to get the oil off the plates themselves, but don't dry off the rails. The rails need the oil to be there. So, you know, we've confirmed it's moving all nice and smooth, and we know what the top side of it is because it's got these notches on it. On the Z, there's a notch on the top, and on the X, there's a notch. So that's going to be our top-facing side. So, as I mentioned previously about the wheels, we're going to do the first set here, and this is going to be the fixed set of wheels that aren't adjustable. So I'm going to take more of these nuts out. And out of this small bag, these are the offset or eccentric nuts. We just need 2 of them for this step. Actually, I only need 2 of the other nuts as well, but here we are. And basically, the easiest way to do this is you flip it over, you take your wheel washer assembly and put it in the hole from above. And you probably will have to wiggle it just a little bit because when we paint the steel parts to protect them, they have a little bit of an edge on them. But if you just wiggle it, it should break out. And then we'll be taking the larger Allen key and our wrench here. And for almost all of the hardware in the assembly where you have loose nuts, you'll be using the smaller end of the wrench here. And this is for the M5 nuts. And just from the side, you will be able to hand twist the nuts on both undersides. And remember that the round part of the nut will face down here because that is the nylock section, which won't go on easily. So you got to twist it around and do it the other way, and you should notice it twists on easily. And then I'll just be taking the wrench, putting it on the nut on the underside, and then tightening the wheel on from above. And these ones you can snug down nice and tight. You should notice once you're done tightening them down that the wheel still spins nice and freely. So if you've gone absolute gorilla mode and then the wheel stops spinning, you've definitely gone too far. They don't need to be crazy snug. Each assembly on the machine has either nylock nuts, which are a special type of nut that'll keep the nut from coming loose over time, or it'll have what's called a SEMS bolt, which basically integrates a lock washer and a washer onto the bolt itself. And the lock washer puts tension on the bolt so that it doesn't come off over time. And in some cases, you'll have both of those at the same time, which is the case here. We've got both the nylock nut and the SEMS bolt. So those will be held really nicely in place, and you should be able to, have fun spinning them. And now we're going to do the opposite pair of wheels, and these will be on the adjustable nuts. So the order for these will be slightly different. Instead of putting the wheel in first and then the nut in from the bottom, we'll put the nut in first from the bottom and then the wheel on top. And you can see in the close-up that we provide in the instructions that the nut has a bit of an off-center hole in it. And you'll want to make sure that that off-center hole is facing downwards. Feel free, if you don't understand what I'm saying, feel free to zoom in the manual. But that little hole, you want it to be facing towards the bottom of this assembly, this area. So I'm going to start with just one of the nuts. I'm going to insert it. The hole's going to be facing towards the bottom. And then I'm just going to give this wheel assembly a quick flip over and just hand tighten it on. Now notice that you've got the blue arrows for this step, the blue rotation arrows, and so you don't need to tighten down on this. Basically, you can just go until it's hand tight and leave it there for now. And we'll do the same thing from the other side. You'll notice that the round part of the nut will fit into the round hole in the plate. Okay. And now we're going to take these anti-backlash nuts and attach them onto this assembly as well. We're going to be using more of these bolts here. This is the bolt that's most commonly used throughout the assembly of the machine. It's an M5 bolt that's about 25 millimeters long. So first we're going to place the Z-axis one. Now remember, the nuts can be a little bit loose on the nut, and so I'll clarify. Both of these are technically nuts. You've got a metal nut inside of the plastic nut. I hope I don't make that too confusing for you guys, but we've got the two nuts inside the robot head, let's say. And because they could fall out, you just kind of want to place it like this and bring the bolt in from the other side. You'll know where this goes because we show a close-up of it for the machine. But also, oh no, I knocked a nut out. But also you'll see that the notch on the plate is actually matching the shape of the robot head. And so you should be able to match those up. And also, once again, you should be able to wiggle the bolt in from the underside if the paint layer is a bit, built up on the edges. Oh, look at that. It came off again. And then I'll just go and finger tighten this for now. Now notice again in this step the rotation arrows are blue, so we're not going to tighten down on this. But what I am going to do is I'm just going to tighten a little bit because the bolts are quite long and they kind of stop out on the nut a bit soon. So give this about, I don't know, let's say 4 rotations. And just stop there for now. 4 to 5 rotations, let's say. So you should notice that the nut is still on loosely, but it's not really going anywhere. And we'll come back later and we'll tighten these up, so don't worry about it. We're also going to do, so this robot head, this backlash nut, is for Z-axis motion, and the one we're putting on here, this is going to be for the X-axis motion. So it's going to face with the bolt that sticks out, it's going to face into the center of the gantry. And so we're going to use the right set of holes here. And it'll be, I know there seems like a lot of holes here, but when you go to line it up, you'll see that only one set of holes works. The other set of holes is used for the extended version of the machine. And we're just going to, once again, we're going to bring the bolts in from the underside. You might want to move the Z gantry out of the way so you have better access. And I'm just going to give it a wiggle and then do the same process again. This is kind of zen, huh? It's not, it's not like you're building a nuclear reactor or anything. You're just kind of having a fun time. While I'm screwing these on, I figure it's worth mentioning a lot of our machine is actually made locally to the Waterloo, Ontario, Canada area. Ontario is a province, and for anyone outside of Canada, Ontario is a province in Canada, near Toronto, or Toronto is part of inside the Ontario province, and Waterloo is a city inside of Ontario, which is the city of Waterloo is also kind of near Toronto, but we kind of do our own things off to the west. Oh no, let me go grab that. Anyway, it's really cool that we're able to do a lot of the manufacturing. A lot of the manufacturing in the local area because, well, how is that not cool? As much fun as it is to, and I say fun in a bit of a sarcastic way, as much fun as it is to just find manufacturers overseas and get them to bulk manufacture everything for you, it's not actually fun, which is why I use the term sarcastically. I think it's really cool, and I much prefer supporting the expansion of local manufacturing, supporting local businesses that we can kind of work alongside. Just kind of like, being an independent city. Not like, obviously, being in a society is great and all that, but it's cool to be able to do your own stuff too, right? So, yeah, like all the steel parts you see, from the plates to the feet to even the control box has got a steel enclosure on it. Those are all made by a business about 20 minutes from here, and we love working with them. And even the aluminum extrusion here, that's also made by a local business that does some auto parts as well. And so we work with them. And I guess I won't point out everything, but yeah, there's quite a few of the things that you'll see in our kit that are all made, you know, within a 1 to 2 hour radius of our shop here, which I think is pretty cool. And yeah, and then we do still get some stuff overseas, like, you know, bolts and nuts and you know, stepper motors. But who knows? Maybe one day we will be ordering enough stepper motors that we can start encouraging maybe a manufacturer here to start making stepper motors. You know, you kind of gotta, that's the kind of the weird thing about manufacturing is you need to justify the manufacturer existing, you kind of need the demand to exist. And for the demand to exist, they have to be making things with the parts already that there is no manufacturer making. So then you kind of got a chicken and egg problem that you have to solve. And for us, what we're hoping is we can start by buying some stuff overseas where it's impossible to buy it here currently. But then if we have a high enough demand, we can start reaching out to local manufacturers and say, hey, if we ordered like a bunch of this from you, would you be able to make it here instead? And then that'd be kind of cool, right? So anyway, we got the second nut on loosely. My tangent is complete. So we're going to take this whole assembly now and turn it back over. And this is where we take this other piece that we put together previously, and these are going to squish together. You can see in the diagram we've got here, you're basically wanting to take this piece and it's going to like slot in here. But the lead screw itself is going to twist actually into that anti-backlash nut. And you can see a back view of it here too. So basically what you're looking to do is you're looking to, I guess I'm using my thumb here. What you're looking to do is you're looking to screw this in using the coupler from the top side. And take your time here because it should screw on very easily. If you're feeling any sort of resistance at all, it means that you're not quite in the thread properly. And so you don't want to just go guns blazing because you could start destroying stuff. You know what I mean? Okay. For me, this nut is feeling a little bit weird. So what I'm actually going to do, and you know, I'm just going to do this for you guys since maybe you'll experience the same thing. I'm just going to grab one of the other lead screws here, and I'm going to put it in the nut from the other side, just to kind of verify that everything's threading on properly. And once I can kind of verify that it is threading on properly, then I'll grab this assembly and put it in the right way around. And, you know, worst case scenario, if it seems like it's not happening properly, you can always grab the spare nut and take the current nut out and swap the part out. Yeah, it does feel a little bit tight to me. Let me see if I can find another one that feels a little bit better. Oh yeah. Oh yeah. See how much easier that is? I can easily twist that with my hands. So this one, I'm not really sure what's happened to it. You know, we try to quality control everything, but because this is a very important part, if something slips through, we give you the spare. So what I'll just do is I'm going to just switch out the nut that's on here with this one. And while I'm checking the nuts, I might as well check all of them just to make sure that the rest of them seem all right. That one's smooth. This one. That one's nice and smooth. And the spare one. That one's also smooth. So there you go. It's almost like I staged this. We just had the one problem nut, so I'm actually just going to put the spare one together and swap it out. And you know what that means? It means I have more time to talk to you about other unrelated things. Let me think. Oh yeah, I should probably have a little sip of water by now. It's important to stay hydrated. Shout out to the really fast LongMill assemblers, who I'm sure are watching this video at 2 times speed right now. I hope you're having a good day, and I'll see you in the future when you're done faster than me. Did I mention that I designed the entire assembly process for putting this machine together? And so, yeah. My pace is staggering. You can see where I'm clearly at an advantage. Okie dokie. Now, for any of you who didn't have this problem, I'm sure you're just hanging out right now. I hope you're having a good day. I hope the weather's nice for you. Today is like the first nice day for us. I'm definitely going to spend some time outside after this. Some other trivia. This space that I'm in right now is our dedicated workshop. This isn't a set. This is the space we actually use to, well, this is the space where we put together the first prototype Mark II and tested it, and the extended version, and I don't know if you can see the machine behind me is legitimately the machine we use for testing everything. Well, basically everything that we ever test or we film a video or whatever here in the office, it's on this machine. And it's kind of fun to do it that way because, you know, we have it set up very minimally to kind of replicate what you might have at home as a very minimal setup. You know, it's not even a purpose-built table, it's just a random table we're using for it. And also, because we use it all the time, it's able to show us if there's anything we've missed with designing the machine. You know, we use the machine just as you guys do, and sometimes we actually use it to manufacture parts for the machines we ship out. So it keeps us more in tune with, you know, what you guys might experience using your own machines. And that's why we can usually speak quite confidently about maintenance and design and stuff like that, because we use it all the time when we're using the machine ourselves. So, all right. Let's get this on the right way around this time. Okay, that's feeling really nice. So we're just gonna screw this into place. And you don't have to screw it all the way on. And then you're gonna see that you can put 2 bolts in this, the X-axis plate into the Z motor mount. So that's what we're gonna do. From the front here, and screw these in. If it seems like we haven't progressed very quickly, don't worry about it. The way we actually laid out the assembly, the reason why you do this first is because it's actually, if I'm honest, it's the most complicated part of putting the machine together. But it's also the most compact. And so it's just easy to have as a starting point for assembly, because it's easy to have in front of you, and using it to get used to how to put the machine together. I'm just going to check that before I, fully ream down on this, that this plate, the top of it should be mostly aligned to the top of the bracket, and the plate should be aligned on the tops mostly. And also, you should be able to really freely spin this coupler up here, and it'll move the Z-axis. And so with all of that stuff confirmed, I can take the short end of the Allen key here and just give this a nice tighten down. Okay. Yeah, that's still feeling good to me. Shouldn't have too much resistance. Now that we have got this all together, this is where we're now going to tighten not the X-axis robot head, but the one for the Z-axis, because this Z-axis assembly is basically complete at this point. And so you can go tighten these down. Now, when you tighten these down, you want to alternate between tightening one bolt and then the other. I usually would do maybe like a quarter turn alternation between them. And the reason why is because you can imagine if you twist the bolt, it can twist the robot head, the anti-backlash nut. And if it twists the nut, then it doesn't stay aligned to the screw. And so that's no good. So we just kind of take our time and go back and forth. Until it's all snugged up. Nice. And one other thing that I'm going to do is, just because this is feeling a little tight to me, is I'm just going to loosen off these bolts again slightly. And just give it a little wiggle. And actually, I'll bring the gantry all the way up to the top here, just so that this is all kind of aligned as we want it to be. And then I'm just going to go and tighten these down again. And it's the same deal here. You don't really want to fully tighten one of them before you fully tighten the other. You kind of want to get them both close and then alternate. Okay, that's still feeling, I think that's still feeling a little bit tight to me. So what I'm going to do as well is I'm just going to loosen off the brass nut here and allow it to open up the gap just a little bit, because, these might have been pressed a little hard against each other. And then I'm going to retighten this. Okay, that's feeling good now. It should feel like you have a little bit of resistance. It shouldn't be free spinning or anything like that, but it also shouldn't be exceptionally hard to rotate this coupler with your fingers here. And that's because if it's hard for you to twist it, it'll be hard for the motor to twist it, obviously. And if it's hard for the motor to twist it, then you might not get reliable movement. So, the motors can only take so much load on them. But I'm pretty happy with this, and so we can move on to the next step. We're going to take out here the rudder mount. And this one, as I said, is the one that works for the Makita router. So it's got a 65 millimeter bore in it to hold the body. And your mount might come with the bolts on it or not come with the bolts on it. Either way, we've got plenty of extra of these M5 bolts. So you can just kind of finger tighten these on. You're not going to tighten these down fully until later when you actually put the router on this mount. And then this mount is symmetric, by the way, so the front goes on either way. And then you're just going to put this, you'll see there's only 4 more holes left on the Z gantry, and those are the 4 holes that'll line up to the 4 holes of the router mount. So usually I like to kind of stand this up and bring this in from behind. You can also twist the coupler to bring the gantry lower down so that it's a little bit easier to balance. Ta-da! And then the mount just kind of aligns flat to that. Oh right, I can't put the bolts in now. Oops. That's a bit awkward. Okay, you'll have to bring it up a little bit. So you've got these bolts that come in from behind, and you screw them on from in front. I'm going to be honest, putting the first bolt on is probably the hardest part, but once that is kind of loosely on, it makes things a lot easier. Yeah, there we go, I've started the thread. Because now you can kind of lean it. Now you don't have to do these in any particular order. I'm just putting them on one at a time, whichever one I choose. And just like what we've done in the past, where you've kind of got paired up hardware, you're just going to bring them all so that they're kind of tight on there. And you can see this step, we have got the red rotation arrows, so they will be tightened up all the way. So bring them all so that they're kind of tight first, but just start with a very loose attachment, and then you work your way from there. The good thing about keeping them all on loosely at the start, and by loosely I mean, you know, the bolts are still sticking out quite a ways, is that it's much easier to get them aligned to the threading on the other side. You may be tempted at some points like this to pull out some sort of impact driver and, you know, give a quick tighten on these, but it's really not necessary. If you use an impact driver on a lot of these steps, it could have the ability to damage the material you're putting together. And also the spring washers can be permanently deformed if you really crank down on them, which gives less insurance that they will stay in, that the bolt itself will stay in place over time. So you don't need to bother, basically. The Allen key is the way to go. Oh my. If any of you have kids helping you assemble your machine right now, hi kids! It's cool that you're here doing this with us. I remember when I was young playing with Lego all the time, and it was so much fun when I got a new Lego set. I know some people think that IKEA furniture sucks to put together, but I like putting it together. I usually never use the manual because it's kind of like its own sort of puzzle. That's how I like to think about it. So it's just cool to see how things go together, in my opinion. So I hope you're enjoying yourself, kids. And you've got a very cool mom or dad if they're doing this with you. Okay, well that's on nice and tight. So there you have it. We're done this first section. We're going to move on to the y-axis gantries. So I'm just going to put this off to the side for now. Maybe I'll put it to the front here, so you can kind of check it out. And we're going to move on to the next page.